Well, hello, everyone, and welcome to this live webinar with the CEO of Delta Gold Technologies, Mike Jones. Now, for those of you that don't know Delta Gold, it's a quantum computing play focused on researching the use of nano gold in quantum computing. So before I hand over to Mike, who will go through the company's latest presentation, I'd like to encourage everyone who is watching or indeed streaming this to share the broadcast, as this will really help the company reach out to new investors. And we'd really like to encourage engagement during this webinar between investors and the company. So the format will be Mike starting off with the latest company presentation for about 15 to 20 minutes. And then we'll go to questions already submitted online. And any further questions you have, please either drop them in the chat or comment on the stream feed that you are currently watching on, and we'll pick them up. And of course, if during the presentation you would like to ask something specific about what Mike is talking about or want more details, please do let us know in the chat, and Mike will be very happy to address them, I'm sure. Well, without further ado, let's bring in Mike Jones, the CEO of Delta Gold. Mike, welcome on. How are you, first of all?
Yeah, thanks very much. It's great to be here and great to see all the people interested in following along.
Absolutely. I think we had 70 people registered. We've got 65, so we've nearly got a full house there, and hopefully more will join as we go through. But what I'd like to do, first of all, is just hand over straight to you for the presentation, and we'll keep an eye on the chat. And if anyone has any questions, I'm sure you can give some more color if needed. But Mike, for now, the floor is yours.
Sure. Well, thanks very much. So standard investor disclaimer, we will make forward-looking statements, and we will obviously seek safe harbor in that regard. Just a quick note on the executive summary. I really think the important thing here is the value of the intellectual property that we're pursuing. We'll talk quite a bit about what's happening in quantum computing, the scale of investment that's happening. We're really in an incredible sector that's getting an enormous amount of attention, and we believe our intellectual property is extremely valuable. So that's really the executive summary. We're listed on Aquis. We're also tradable on the OTC market, QB, and we have a listing in Frankfurt as well. Importantly, many of our early investors are EIS investors, so they're incentivized from a tax perspective to hold their shares for 3 years. And we have active research at University of Toronto and at Penn State in the United States. Our basic corporate structure, we have 66 million shares outstanding. The founders continue to hold a very significant position, and we have some very sizable shareholders as well. So of our overall stock issued, over 50% is reportable, and we have some very loyal and stalwart shareholders, as many of you know. Just a quick primer on quantum for those of you new to the story. So as everybody knows, a computer deals with zeros and ones. You have 8 of those bits, you have a byte. And of course, we're all familiar with megabytes and gigabytes and so on, the basic formation of information that goes into a computer. A quantum computer is very different. It deals with a 0 or a 1, but also any state probabilistically in between. It's dealing with quantum physics. It's fairly hard to understand, but the important thing is that this technology can have implication across sectors, from encryption to banking, to military uses, to modeling molecules and drugs. It's an extremely powerful computing system. So far, we haven't seen a computer take what's called the quantum advantage. In other words, be commercially reliable and stable enough that we can solve real world large problems. But the potential is definitely there. And that's why there's literally tens of billions of dollars going into this. The market has changed completely. This is a new slide many of you may not have seen, just talking about the amount of investment from private investment over the last few years. And it's actually up 6 times since 2024. So we're talking about $12 billion in 2025 alone of private investment into quantum. And the government line at the bottom is much lower. However, that doesn't count 2026, when the US government put $2 billion into quantum companies. So the US government has very much stepped in here and gotten very involved in quantum, and really sees it as an important race for the West, and particularly the United States, to win. We're also very proud to be part of a documentary screening here in the UK from the National Quantum Center. And many of you in the UK may not know that actually the quantum investment made by the UK government. It's about $1 billion into the National Quantum Center. Just a basic outline of some of the quantum companies out there. So interestingly, you're looking at something like tens of billions of dollars for the larger players like IonQ and Rigetti. And then even in the smaller players, a company like Arcit, which is probably the closest to us analogy, is several times our market cap. Xanadu is actually also listed on here. They're a $3 billion spinout of University of Toronto, and we're well aware of their technology, and we still remain very confident that we have something very revolutionary compared to their particular approach. This is just a chart of funding over time. I think this is important for everyone to get a sense of the amount of investment that's again gone into quantum and the trajectory of companies like IonQ and Rigetti that are multi-billions of dollars. They really started their larger funding rounds around 2018 or 2019. And just a few years later, they're raising $50 to $1 billion at a time. One dot that's particularly of interest to UK investors is the $1 billion equity raise at the top of the IonQ chart. That's actually for the acquisition of Oxford Ionics, which is a company that built an interesting toolbox for looking at electrons. In fact, one of our principal investigators called it a cute science experiment. Well, that cute science experiment was a $1 billion cash takeover of a university spin-out company. So if you want to look at what research at universities can do, there's a concrete example in just 3 years here in the UK. This is a fairly complicated chart, and I'm not going to go through it in great detail, but I encourage you to study this on the presentation on our website. So there are two main attributes that have to do with how successful a quantum computer can be. Number one is the scalability. Can you make literally hundreds or millions of qubits? And the second aspect is how stable those qubits are. How long do they stay available in order to make gated transactions? In other words, to make a computer out of it. And on the two extreme ends of this are, in the top left is superconducting. This is the method that's used by IBM, Microsoft, and so on. They're looking at superconducting qubits. They are extremely scalable. They can make lots of them, but they're very unstable, lasting for a millisecond, if that. And so they're very difficult to work with, and they require a lot of error correction. And we've seen recent announcements from IBM about their reaching the quantum advantage. However, when you dig into the detail, the statistics are such that it's really not ready for prime time and a major scientific calculation. They're talking about error rates that are in the 0.00015% range. And even with that, there are still errors at that error rate. So it's very challenging. On the other end of the scale is trapped ions. And these are literally holding a single atom in a contained field, put there with lasers and held there. And they're extremely stable. In fact, they can get quite long coherence times. The problem is that the infrastructure to hold that single atom is quite bulky. And imagine trying to do millions of those that are connected to each other. And of course, as soon as you connect them to each other, it creates noise, which creates a problem. So although they're very stable, it's very difficult to scale them. So our target is the top right, which is both, in that we're looking for a very scalable solution that we can make millions of these things. And we're looking for stability that goes beyond the millisecond range. And that's what our science is showing promise for, is something that's very different than the other modalities. In fact, it's a completely different modality than other things that are on the map. Again, this is a very complicated slide, but I think it's worth talking about. This really has fallen out of the recent meeting in the UK. And really the main reason for this webinar is we want to talk to this slide. That we are seeing a development pathway now that's very clear towards where we want to go with a device at the end. And we have early breakouts on the top and bottom. So the top area is the Penn State pathway, the various milestones we have for the research that comes from the research program. That research program has now just been expanded to $6 million over 6 years because of the development pathway we see in front of us. The top and bottom breakouts are about making a quantum sensor. And this is something we haven't talked about before, really. The ability to use a quantum device or a quantum subject as a sensor for what's going on in the environment around it. One very exciting area in quantum sensors is actually about quantum navigation. And I don't have time to go into this too much detail, but you're basically using a quantum situation to measure very small changes in magnetic field or the gravity in order to be able to navigate and not rely on GPS. This is a very important development that particularly the US Air Force is very involved in. And many of you have asked about our recent visit to the White House. I'll talk about that in the Q&A a little bit. But this is an area of forward deployable technology that's of extremely high interest. So I can't talk a lot more about that, but it's something we're very excited about in the near term milestones of the company and the direction. Also in the middle of this chart is actually a combined device. So this came directly out of the collaboration between the two universities. They're using gold for a fundamental reason that's the same, but they're working on it in two different device pathways. The top one is using an optical method excited with lasers and how optics happen. The bottom one is electronic. And so there are possibilities to actually work both of these systems together. And that would be truly brand new, a completely different device that does not exist. Just briefly, we've talked about our two research agreements, one with University of Toronto over 3 years. Again, 100% ownership, exclusive license on all of the forward IP, led by Dr. Harry Ruda, one of the top scientists in the world. And our research agreement number 2 at Penn State, a 6-year agreement now, we've expanded it. And both universities get between a 1 and 1.5% royalty. Ken Napperberg is an amazing guy. He's also an elite marathon runner, among other things, and a professor of physics and of chemistry. He's the head of the chemistry department at Penn State University. And we're looking to expand this now as a center of excellence, looking to work with potentially UK universities and also other professors and ways of doing research, which is currently in the works.
Mike, can I, sorry to interrupt. I'm just being told the PowerPoint isn't formatted so well. So I'm just going to see if we can swap. That looks a bit better. Are you able to control this one?
Nope, but you can go ahead and advance it.
Okay, I'll advance it, no problem. Okay.
Yeah, go ahead to the next slides. So yeah, we've talked about the Center of Excellence. We've filed provisional patents at University of Toronto, and we also have 3 full patent applications and again, important to remember that actually the universities themselves have elected when it's time to go for disclosure and patent protection. So it's not something that the company is just pushing this. The universities are saying, this is an important, as they call it, a eureka moment for discovery. It's time to protect it with a patent. Go ahead, the next slide. So how do we get to revenue? Many of you have asked that. So the stages are pretty simple. Fund the research, own the research, protect the research with the patents, then license that research and collect royalties on those licenses. That's our model. It may be that we end up with partnerships, which are a different form of collecting revenue from the patents. And all of that will be explored between 2027 and 2028. We'll start into those discussions. And of course, because we have exclusive licenses, we control between 98.5 and 99% of the potential revenue from that intellectual property. This is a very big number, 2.7 trillion. And we just wanted to talk about, it just looks like we went back a slide. There we go. 2.7 trillion is the scale of what's estimated to be the size of the quantum business in 2035. And this is from McKinsey. There's a very good McKinsey report. If you send us an email, we'd be happy to send it to you. It's an interesting report on the entire quantum business. And this just shows the diversity of sectors that are involved in quantum in the future. The amount of potential revenue and business in each one of those sectors, the economic value. Sorry, do you want to advance the next slide? We've talked about our board of directors, obviously a very diverse experience set. Patrick Severide is independent as a NED. He just reviewed actually some of our ongoing contracts. He's a very active director, very useful. Adam is on the finance side. Jamie Toss is in operations, very experienced with public companies and raising money and listings. And Mark Burnett, who many of you might know is our chairman. Go ahead, the next slide. In terms of timeline, where we are, we've really hit a lot of our milestones over the last 24 months. Quite incredible as a company starting out. And we remain fixed on IP licensing and monetization in 2027. We do see a lot of news between there and now. Expanded university agreements, we're very much on top of that. And we also see the opportunity to look at a breakout into quantum sensing and into quantum information. There's some other work that we're doing that'll come into the fore in the months ahead, but both quantum information and communication and quantum sensing are specific sort of low-hanging fruit in terms of developing our technology into those areas. They have very specific advantages: the stability, the robust nature of the technology, its opportunity to be in the forward area, as they call it in the US military, is very interesting from a research sponsorship point of view. Some of you asked about why we went to the White House. It was really to report in on our technology because we believe it's extremely important in the US context. And that will open up various avenues of conversation to the agencies where the detailed work is going on. And maybe I'll talk about a little bit more about that in the question and answer. But quick summary, we wanted to make sure everybody understands what's happening. And we are more convinced than ever that we have a very powerful technology that is not replicated in the other modalities. The new deck is available on the website. And maybe we can go through the questions, Mark.
Absolutely. Thank you very much, Mike. Nicely on time there. Apologies for the formatting of the PowerPoint, but we know for next time to use PDFs. 100 people are watching, Mike, but let's get straight into the questions. So the first one that came in was, what happens to the share price if someone gets to qubit first? Have you accidentally landed on other ideas away from the qubit to further add value to the share price under the wrapper DQG, especially with the new super brains recently added to the team?
Those are great questions. So I think it's important that to remind everybody, this is not a digital situation like we win or we don't. There's a lot of quantum technology being developed across sensing, communications, and quantum computers and quantum information. I think there will be different applications and different systems for different things, much like there's Microsoft and Apple today. There isn't one laptop computer system, there are several. We do firmly believe that our technology has application into quantum information systems, that actually the systems that are there, we have the potential to beat, to be really frank, because of the stability and the scalability of the systems we're working on. We're dealing with the top scientists in the world that have decades of experience in this space, and they believe we're driving for something that beats whatever else is out there. That remains very much true, more true today than it did when we started. Absolutely. But on the quantum information systems, that's not the only goal. Quantum sensing and quantum communication is very interesting. And we see our technology actually having a natural advantage early to demonstrate its benefits. It's more difficult to make quantum gates in an actual quantum calculation device, but to be able to show it as a robust quantum sensor or involved in the quantum communication of information, that's easier. And so we see an early breakout towards really almost a separate business line with a separate set of patents and a separate set of partners in those areas. And that really came out of the collaboration between the two universities.
Excellent. Thank you, Mike. So the next question I have here is from Alex Brazil, who also actually posted something in the chat. So I will get to that one straight after this first one. But the one he sent in advance was, how will you scale up the research and patent applications? When will you be in a position to start commercializing the patents?
So we're scaling up our patent effort as we speak, actually. So we've got Hayes and Boone as a very experienced patent team, and they'll be working on how to and when to actually file the patents. That's a fairly tricky strategic area. They've filed 19,000 patents out of that office, so they definitely know what they're doing. And we will be working on scaling that up, that part of the effort up in the months ahead, certainly. And in terms of commercialization, we've set a goal of 2028. We do think, though, there's a lot of news between here and there where we may have the opportunity to partner, specifically in business segments where there is a lot of specialty knowledge in those other verticals. And that's something we're going to be working on. So, stay tuned. We've got a multitude of facets there, to be honest.
Excellent. Good. If I could just bring in Alex's other question here that he asked in the moment.
Sure.
How do you plan to raise awareness in the United States?
Oh, that's a good question. How to raise awareness in the U.S. We have worked with some very senior public relations firms before in our group. We're at the stage now where we're ready for that. And actually, interestingly, we were told we had to go and report to the White House before we started working on public relations, because the last thing that they wanted was the White House to read about it in the newspaper. So we had to go and salute the flag, which we did. So we do have a plan, and it is challenging. I mean, as a small company, getting bandwidth out there is a challenge, but we've now got the goods that we can start to do it, and we've reported to the government as we felt we should.
Okay, excellent. Thank you, Mike. So the next question I have is from Francis Jackson. Do Penn and Toronto universities work closely together, i.e. collaborative, or are they really working independently but with a common objective? And would the addition of a UK leg complicate matters? Who is responsible for the coordinating of the university research?
All great questions. So actually, the collaboration is almost daily. As a result of the meeting in London that we had to bring the scientists, the principal investigators together. And so there's a lot of great excitement around combining that knowledge base. It was actually really cute. I said to the professors, you must have senior level conversations with your postdocs and your research team all the time. But I noticed you were very excited to talk to each other. And of course, they said, no, like we don't get to talk to people at our level very often, right? It's a very rarefied space. So they were literally like two kids in the sandbox who like to play together. It was really quite exciting. So there is a lot of collaboration actually is happening almost on a daily basis. However, they are working on different channels. They have different ways of using gold. The fundamental root physics is exactly the same. The reason that it works, which I can't talk about, but they are collaborating. And we actually see a potential to do something in a method that's combining both of them. We've actually found a new avenue, if you will, towards a device which may use both of their technologies, which is very exciting. So yes, they collaborate and they're working well together.
Excellent, good.
Oh, and then the third question was about a UK university. So we're looking both to have a very good commercial arrangement with the UK university, which is, of course, critically important, on similar terms to what we have in the US and Canada. Where we have 100% global exclusive license and a minimal, relatively minor royalty. But we also want skills that are adjunct and complementary to what we're doing. So we've got a number of conversations going. There are lots of opportunities there. We want exactly the right one. And that's the reason that we formed the advisory board with Professor Davis heading that from Oxford to actually overlook whatever new possibilities we're going to deal with. We have all three professors to collaborate on where can we get the best bang for our buck.
Excellent. Good. Thank you, Mike. So Duncan Paul Mitchell has the next question here. Is it likely that we will see very little movement in the DGQ share price from here until Delta achieves some form of proof of concept and actualization of a commercial application on the gold nanoparticle hypothesis?
It's a great question, which I can't answer. I can never predict the share price. However, what I can say is that there's a lot of good things that we're doing, and there'll be a lot of opportunities to show people what our progressive steps are. So we've got a lot of steps behind us that we'll be able to talk about publicly. And I think, as the question was raised before, we have an OTC QB listing. It doesn't trade at all there, and that's just a lack of awareness. And we're doing a research program with Penn State. Penn State has 800,000 alumni. So there's an audience right away that if we're effective at communicating with, could be very interesting from a US point of view. And, there's enormous interest in quantum building in the United States. I mean, that's why the larger companies are at, 10 billion plus market cap. So, and they're doing, hundreds of millions of dollars in financing at a time. So I think there is a good appreciation in the US, and we, even in a small way, joining that community would make an enormous difference in demand for shares, which is where share price comes from. So
well, that's a very good idea. Yeah, thank you. It's a very good idea to target the alumni there of the universities. That's a good target
we have
audience.
To be respectful about that, but yes, that's an audience that's natural.
Absolutely. So William Andrews' question is, why should gold nanoparticles have benefit over other metals for qubits?
Yes. Well, now we're getting into the root cause of things. And as I've said before, there are 3 people that actually know about that, the 2 professors and me, and I'm not talking. So all I can say is that as published in the Penn State paper, gold's electrons have a very special role, and the way that they are excited and create photonic emissions is very special. And there are electronic things about gold that are very special. So all I can really say is that 2 top universities in the world identified the same element on the periodic table for the same reasons, and are working with them in 2 completely different ways, but that the root is the same. But that's all I can tell you.
Okay, thank you. We'll move to Dean Chapman's question then. When will we likely see a float on the NASDAQ?
Well, NASDAQ's an interesting question. I have more experience with NYSE.A and actually with Guardian Metals listing. I was a strategic advisor there, was able to ring the bell at the New York Stock Exchange for the 3rd time in my career. So I like the NYSE.A. I understand their listing rules and their governance very well. I've been through it a number of times, as I said. And it is something that we aspire to. We would like to have a listing on a major U.S. exchange, and I think it's the right place for a quantum company to be listed. So all I can say is we have it as a goal, and we're working on it.
Okay, good. So Simon Barrett's question is, what was discussed with which department at the White House, if you can divulge such information?
Sure. Yeah, no, we met with the head of quantum strategy for the Trump administration in the office of the president, the scientific office of the president, science and technology. We met the head of quantum strategy. So that's the overall administration top of quantum. So his job is really focused on implementing the executive orders. And the executive orders are very clear to win the race in quantum and have a quantum computer by the end of 2028. So it's a tough order, and the objectives of the departments are to further that goal as much as possible. So we started at the top, and we're very pleased to have a very good lobbyist representation firm and a public relations firm that we're working with. That'll become more public in the next little while. And now we are in a position to be able to go back and meet with the agencies. So we've saluted the flag at the top. Now we can work on the various places that are actually administering it. And we've been directed how to do so.
Okay. And sorry, just a follow on from me on that. Is it fair to say you're sort of in the inner circle, or no, maybe not the inner circle, but you're sort of approaching a circle of the White House there? You're sort of in with the people at the White House. Is that a fair thing to say?
I mean, I wouldn't want to characterize things that way. I think we need to be more diplomatic than that. I think what shareholders can take away is that working with Penn State and the technology that we have, we have the attention at the very top level. So that's a message, right? You don't get that meeting if you're not interesting. So I think it is a marker of doing something important with very good people that we're working with. And I think that's a theme that we will have resound over and over again, that yes, this is a small company, but we're working with the people that work with very much larger companies. I mean, our lobbyist works for mostly Fortune 50 companies. So that's how you get the doors open. You have to work with the right people, and we have the network to be able to do that. And we have the experience to do it. I mean, we know how to work at a top level and do things like a New York listing and grow a company to the 500 million plus level. Our team has done it more than once. So that we're not working at a small company level. We're working in the sphere that we want to be in, which is a much bigger company.
Excellent. Well, let's move on to Michael Higley's question then, and it is, what are the key technical and commercial milestones Delta needs to achieve over the next 12 to 18 months to prove that its nanoscale gold technology has genuine commercial potential and attract strategic partners?
I mean, that's such a good question. It's really almost the wrap-up question of the session, to be honest. So listen, that's something that I think we need to do a better job of setting out those milestones. I mean, to be honest, the box chart really was the first strategic roadmap that we developed from the professors' collaboration. And I think over the next month or so, we'll get much clearer about exactly what the timeline is. However, I would say that over the next 12 months, we expect a series of patent applications. We expect clarity on the initiative into quantum sensing. We expect some response from our government engagements. And we expect to be able to really show that we have a competitive position through the fundamental science. So I think those are really the four things that we're working on. And we have a very clear path on that. We know exactly what evidence we need to demonstrate to generate patents. We know exactly what things are of interest from the government and strategic point of view, national security point of view. And we know how to go and do those things to demonstrate it. So I think the next 12 months is going to be enormously exciting. And we have the finance to do the exact work that we have to do. We're in position to do it right now.
Well, that feeds in perfectly to the next question from Tony Wilson. Is the company fully funded for the current work commitments into 2027? I guess the answer is yes.
Yes. So both our work at Penn State and University of Toronto is funded into 2027. In fact, we're funded well into 2027 until at least a year from now, if not beyond. We also have warrants that are in the money for an additional £1 million. If we add a UK university or a brand new technical initiative, that would require finance, but we're very focused on, matching each stage along the way. So finance to business, back to finance, back to business. You want to turn those ratchets, as it were, where you're growing the business in line, not out of proportion, where you've got more science than you have finance, or vice versa. We don't want to raise money too early because we think our valuation should move. So it's really about turning the dials together in sequence. And we've currently got the program and we have the cash to do the program. It's about telling the story so that we get the market appreciation for what we're doing. And that should open up institutional interest, which brings finance, which allows us to go back and build the business again. So it's that doing it together, set by set, that is our focus.
Okay. Now, I know we've talked about the White House a little bit, but this question from Steve Sherry, who you know quite well, he watches a lot of our content. I best ask it. So you recently attended the White House. What was the purpose of the visit? And should investors be reading between the lines of this type of visit, as there's also been commentary about how Dr. Harry Ruder has potentially changed a few opinions on what should have been the start point in quantum?
Well, I'll address the last part first. Dr. Ruda did his postdoctoral fellowship at IBM. So, some of the science that's based on the work that he did there, he understands a lot better now. So I think that's kind of what Steve is referring to there, that, we're benefiting from the early work Dr. Ruda did, and now we're into something, quite different, actually, which, he believes has potential that's beyond what the work he did originally. That's really what that's about. As far as the White House, I mean, I think, again, as I said earlier, I think what the important point is that, number one, we know how to report to the right places within government. We're doing important work, which I think the meetings in the U.S. show that we're doing important things. And that's what the shareholders should take away, is that this is important work, that the company, notwithstanding its relatively small size, has the ability to get the attention at the very highest level. And there's good reason for that. Number one, we know how to do it. And number two, we have important things that we're doing. This is not just a set of science experiments. This is a very important piece of work. And the quantum advantage is not yet achieved. We don't have an error-tolerant quantum computer. And we've said many times that we believe we need to go back to the beginning, back to the fundamentals, work on the root of the system to make a more scalable, more stable machine. And that's being acknowledged by people who are paying attention to us. So that's what I think people can take from it.
Okay. Well, I have one last question that was submitted in advance, and then I see it about maybe 2 or 3 that have come in live. So let's just finish off with
Sure.
Miles Biggin's question here. The strongest published spin polarization results came out of work that predates DGQ. What in your patent estate is novel and exclusive to DGQ, and where does the boundary sit between what the universities own and DGQ?
Oh, such an aware question. I'm so impressed with this question. I must say, this is somebody who's really thought about this. So good for them. So it's important that the early work was not yet patent applied for, and all of the patents, all 3 of them, are within our current agreement and captured with our exclusive license. So yes, there was early scientific work, but that work generated disclosable and patentable information with experimental evidence, and all of that is within our agreement. So good catch. There was some early encouraging science that was actually funded by the US Air Force. As a result of that early work, we've, it's a statute. It's not that we agreed to it. It's actually a statutory acknowledgement that if the US wanted what they call a march-in right, which is that they could force manufacture in the US and they could force a license for the US government, they could do that because on some of the early work patents. However, our forward-going patents don't have that requirement. Interestingly, that act was instituted in 1947, and the number of times that the US government has used it is 0. So it's not a big area of concern, but it is something that we have to abide by for the earlier generated work. But all of it falls under our agreement where we have a global exclusive license. So great question. And that's somebody who's really watching the P's and Q's of the science. And they're right. There was some early encouraging work, but it all falls under, the patents all fall under our agreement.
Excellent. Okay, let's just do these sort of 3 questions I can see here that have come in. So first of all, I don't know what you can say on this, but can you discuss any tie-ups with potential UK universities?
I can say that we've talked to at least 4 of them, maybe 5, 4 for sure, in detail. We have some very interesting proposals, and we're in discussion. That's really all I can say. There is opportunity to work with some of the top universities in the UK, no doubt about it. They, of course, are very interested in the technical work we're doing and who we're doing it with. So I think there's good potential. We're being quite cautious about it because there are a number of opportunities and we need to evaluate them against each other, to be perfectly frank, which is the reason that we've formally put our 2 current scientists plus Tom Davis at Oxford on the advisory panel to assist us in making those decisions. So we're in the throes of that, is all I can tell you.
Okay. Another question that came in here was, are you thinking of a company name change to include quantum rather than gold?
Yeah, well, that question, change the name rather than gold, that's come up internally a number of times. We've talked about it internally. I'm not really sure why, but I like the current name. And there's lots of quantum Q this and Q that. I'm personally happy with Delta Gold, but if there's a groundswell, we always listen to our shareholders. What can I say?
Okay, thank you. Now, this one's quite a long one, Mike, so let me read it to you. What is the single falsifiable technical milestone in the next 12 to 18 months that would prove gold clusters can act as a controllable qubit or device element rather than just a spin polarized emitter? Very technical question.
Well, this sounds like a question for our professors, to be perfectly honest. How should I answer it? I mean, I do know some of the real detailed physics about this. I mean, one of the things is that we want to see individual clusters emit rather than ensembles of clusters. That's a big one. So we've got to look at that. We also I mean, we know that we can control this thing. We do know that we can change emissions from what we input. So we know we can write to the system, and we're seeing controllable output. It's really setting those parameters and seeing how to manage it is what we're doing. So I'm not sure I can answer it much more than that. I think the forward going aspect is to look at making a device, obviously. And we've got a series of stages in terms of looking at how the emission happens on an individual cluster, and then also what are the parameters around setting it and reading it, to be in summary. So we've got work to do there. We see opportunity to be able to do that work. We know what we're going to do. We know what the experiments are to do it, but it's exactly right. To put it into a controllable device element, that's the next steps.
So 2 more questions.
Sounds like a very technical person who asked that
It was
question.
a very technical person, so maybe it's something we can check back on later, maybe. Yeah. So I've got 2 more questions, then we'll finish. So this next one is, how do you market such tech to the myriad of sectors and industries, and does the team need to grow in order to do so?
Oh, that's a good question. I mean, I think yes, certainly the team needs to grow to do it. I mean, as the quantum sensing aspect develops, that's a whole business development area that's on its own. And quantum communication the same. I mean, there's all kinds of people interested in quantum communication, including the large telecom companies. So certainly the team needs to grow. I think we have time to do that, though. The science needs to lead first, and we need to hit the technical milestones that we've laid out on the box chart. And as we do that, that's where we can start to get into the business discussion. So we've probably got, a good 8-9 months before we really need to engage on the business side. We need the technical milestones hit first.
Okay. And finally then, Mike, nice one to finish with, actually. In a past podcast, you mentioned you only had to be 10% correct. Can you please explain?
Sure. Well, I've described, and this is maybe potentially a bit controversial, but I've described the modalities as possibly a dead-end hallway, that if you can't error correct and you can't scale, where do you end up, right? We need to make millions of qubits. We need them to be stable enough that we can make calculations and create gates out of them. If you can't get out of the current position of the current modalities, then surely you would think about a different way of doing it. And what I mean by the 10% correct is, we have our own hallway to go down and investigate it to a device. And I think, as the previous technical question asked us, what are the steps that you can show to get to a device? Yes, there are a number of steps, but as we go down through the steps, the interest in the end of our hallway are the doors actually open to a scalable, stable qubit. That gets more and more interesting. And there does come a point when someone says risk versus reward, I don't really want those guys to go try all the doors at the end on their own and see what happens. I'd rather either own it or license it. So I don't think, as the science advanced, I think it can be a very interesting conversation as we go along, not just at the very end, which goes back to the conversation about, is this a digital outcome? Do we actually prove it all the way and it's worth, a lot, or it doesn't work and it's not worth anything? I think there's a whole conversation in between, which is there is a probability here that this is a very interesting technology, and it may take other steps to develop it. And what are the partners and the licenses that have to happen in order to license it to go further? So I think it's different than a digital decision, and it has a lot of value as it advances the science.
Okay, excellent. Well, thank you very much, everyone, for watching. I hope you found it useful. It's certainly very interesting, isn't it? Of course, this technology, very exciting space to be in. So thank you, everyone, for your questions. And of course, thank you to Mike Jones, the CEO of Delta Gold Technologies. I'm sure we'll be hearing a lot more from you in the near future.
Well, my pleasure. And whoever asked the very technical question, send us a note on the info account, and we'll try and get you a more technical answer from professors themselves.
Excellent. Well, thank you, Mike, for your time today.
Thanks a lot. Thanks for the time, everyone.
If you enjoyed this interview, then give us a thumbs up, a like, or a retweet.
subscribe to us on YouTube or follow us on Twitter and hit that notification bell to be the first to know when we release new content. There's loads of great content on our website too, across all our programs at StockBoxMedia.com. Thank you for watching.